So, thank you very much for joining me today. I'm Tom Ohtsuka, the third presidential candidate for the United States. Sorry, joking. The founder of Team Matrix. Today, I'll bring you to the next frontier of AI development. We are here at the pivotal moment for AI development. Today, I'm excited to announce and unveil the Team Matrix, the first AI engineer, redesigning how we build AI by letting AI autonomously develop the other AI systems. This is not just a product launch. It marks the beginning of the new era in AI development. Where we are today, I'm sure many of you come here today to the AI conference because you may have some challenges in developing your own AI, mostly based on LLM. And you look for some new idea or approaches to solve it. Yes, I'm sure the LLM-based AI development is very challenging. Let me quickly deep dive into some developers' dilemma. For examples, new models rolled out every quarter. Most of them start that they are performing better than the others and some public leaderboard. That's of course true, but when you start using reported better models in your application, it starts working totally differently. And sometimes the quality even looks degraded. In a more daily LLM of scenarios, you may have weeks of prompt tunings. Based on some qualitative feedbacks on your LLM-based application, you add some instructions about rules or behaviors or forbidden answers into your prompt text, and the reported issues are fixed. But after you commit your new prompts to your Git, new bugs and noisy behaviors are newly reported by overly referring to new rules in other cases. After all, you revert back to the original one. Such surprises upon updates also happen in lag development. You must update or increment new data to your vector database to refresh and cover bigger knowledge, but once the size of semantic structure gets different, your vector database returns more noisy documents than before, which eventually leads to the failure and the quality of grounding. To recap the developer's dilemma, in LLM AI development, updating one part of your LLM architecture to fix a particular issue causes degradation in some other areas. And there is no universal best practice that fits all. Therefore, it's very challenging to find the optimal architecture among the infinite number of options. And this challenge is unique in LLM-based AI. So for example, in web engineering, bug fixes can be easily reviewed from code source and define quality assurance process, and we can easily know the problem is fixed and improved. In machine learning, for example, the more epoch of learnings you go through, or that you get clearer databases or datasets to base for learnings, the better results you should get in general. But in LLM-based AI building, it's more like a random approach. You find problems, you may find some issues, you fix some new approaches, then you try another approaches, but another problem rises again. You fix it, but the previous problems occurred again. Or every month you are aware of some new techniques or approaches you wish to try, or you may find some new approaches in the AI conference. But even if you find that it works well in your local Jupyter notebook level, it's very hard to immediately apply in your production applications. And after you try a lot of loops and look like you found a good one, but there is no structure and visualized scores to report to your boss or the business team how it's the optimal. Moreover, these processes currently require extensive manual effort, which is far from ideal. But you should be the one who is enthusiastic about the power of LLM, and believe someday you could find an application or agent that handles most of the human job. If your LLM AI building is super complex, how about letting your job to LLM AI? Let AI do it. As an enthusiast in LLM, we came to an idea that we had an agent that works for 24/7 hours to iterate at scale. The agent tries to understand the context and challenges with the reasoning and statistical analysis, and the agent widens the idea of potential solutions and tries on behalf, while it tries to align what human developers prefer. Then human AI engineer will be an objective instructor and an AI work approver, while AI handles the actual DevOps heavy work of LLM AI building. So today, I'll officially announce the concept let AI build AI. And I officially announced today the unveiling of Team Matrix, the first AI engineer as a beta version to you. The AI engineer develops AI, evaluates AI, and optimizes AI autonomously like an AI agent. We still create some human intervention at key checkpoints now, but it works to fulfill the objectives and some feedback from human AI engineers. Team Matrix AI agent is designed to follow the best practice of LLM iteration cycle. In an organized practice, a human LLM AI engineer drafts LLM architecture with module choices, prompt text and lag, and then test with the prepared test patterns, simulate and label the score with human labeling team, instruct labeling team to consistently judge, and run data science to analyze and identify the quality of the performance. And if problem is found, they draft the alternative architectures. Our LLM AI handles everything here on behalf. Our AI builds AI by following these steps to run drafting and iteration. To deep dive our experience, it works like this, but let me drink water. Okay. So, in our platform, human AI engineer tells the project objectives. Then the AI engineer generates prompt text and lag. Then human AI engineer tells a particular use cases of the project. Then the AI engineer generates text input cases that the users of the project may likely ask. Then a human AI engineer tells priorities in the project. Then the AI engineer drafts the evaluation metrics and criteria instructions based on the priority. After human approvals all of that, AI engineer review each generation log to judge. Then aggregate analyze the trend and deep dive into poor-related logs, find problems, then draft alternative approaches to the issues. Reevaluate the performance again, then finally find the optimal solutions. During those process, the role of humans is to appreciate for the AI works, like drinking coffee, come up with more creative ideas, or some more time with your families and pets. This is like a new experience we try to bring to you. And this is not a substitute of your work. Our AI catches up with the latest technical choices potentially effective with details in it. So it tries to even some minor techniques that may not be worth trying manually by you. Or from simple model version switches and prompt defining and even 1 or 2 word level, to lag chunking sizes updates, even model temperature changes, or breaking generation into several smaller steps. Overall, the work you should do as a human agent and AI engineer is, from today, be more creative, or be more precise in the objective and purpose of your AI. In our testing, the more precise you give to the AI and the objective instructions, the better and more complex proposals our AI may present. Then you may say, hey Tom, you told us LLM is very hard to develop and control. Then how capable an LLM-based AI Team Matrix is? Now, so let's deep dive into the developer's experience. So first, on our platform, let's start from letting AI draft LLM architectures. You give the first objective of your project. Then the AI crafts the initial prompt and prompt text and architecture of LLM. Even with the initial architecture, you can get started with learning a generative app that is tailored to your needs. But to iterate and improve to reach to the proven level in the productions, you run evaluations and optimizations with AI. So as a second step, let AI create test cases. We first need test cases for consistent evaluations against multiple development options in LLM architecture. But our AI generates input text dataset based on your prompts and generation logics. Test cases require a fair balanced composition of the dataset to avoid over-optimizations. In order to achieve that, based on a prompt text and lag on objective and use cases, given my lag. So this is how our AI works in creating the test data case. But it first generates topics with the probability of their occurrence, then generates a potential user input for each of the given topics at a specified number. So by those generation 2 steps, it ensures the test data cases to base for your AI is actually fairly grounded. Next. We also need metrics to evaluate the quality and performance. So let AI create evaluation metrics. As a general basis, we believe LLM as a judge is an efficient method to evaluate the quality of LLM responses at large scale, while human may perform better in some cases, but typically far more efficient in efficiency than traditional human evaluations. Traditionally, especially in machine learning or reinforcement learning from human feedbacks or RLHF, we had a human evaluators and labelers who scored the results as a trainer. But LLM is at the satisfactory level now to evaluate the text with predefined instructions. We already have some open source projects of the LLM as a judge, but they try to cover the universal one, which is good, like a bias, toxicity, which is fine, but we started it may not suit every case and every business needs. We believe metrics tailored to each case better fit in evaluating its quality. Here, our AI creates custom metrics. For example, in customer support agent case, our AI creates 5 criteria on friendliness, politeness, or helpfulness that goes beyond expectations. In sales agent case, for example, AI creates instructions to evaluate the call to action effectiveness and value proposition accuracy. Or in some cases, like a chatbot, whether it follows the character guideline, or like a case of function callings and agentic architectures, or agentic architecture applications, it creates a metric to judge whether the function selection is appropriate or not by yes or no criteria. These are just one of the visualizations of how the creative AI drafts evaluation metrics to tailor specific use cases, but this works in any cases very flexibly in any domain. Then after all of those setups are complete, AI starts evaluating your original plan autonomously like an AI agent. Generally, it is designed to 1. Simulate generation outcomes from the generated input test cases. 2. Evaluate simulated logs based on the generated metric instructions. 3. Analyzes the evaluation results quantitatively and qualitatively. Results are visualized for human reviewers, but this is actually automatically analyzed. And 4, summarizes the analysis results and construct a problem narrative forming the basis for the alternative strategies. So during the process, it is not like linear. Our agent is designed to go back and forth, and if there's any further problems to deep dive, then AI goes back to query the results or see the logs to find the much deeper problem and why some issues are happening inside your applications. Then based on the summary of the analysis, our AI operates to suggest the LLM architecture improvements and identify missing knowledge to fulfill from the available options the LLM is required to get, including some latest techniques and technologies that I identify as I described. So these are to potentially improve your original plan. So let's see what's analyzed and proposed by our actual systems. In one project, AI evaluates we generally have a below average performance in familiarity score, while the accuracy of the answer may be perfect. Then suggest to add more rules and prompt text while the pre-tuning format of your prompts. Or switch to some masked model strong at casual to improve the familiarity. So this is XXX is more going to the actual model, but this are suggested. Or in such model selection, sometimes AI suggests a minor model with strengths in particular domain. Or in another example project, AI evaluates, we have less accuracy scores and topic of refund due to lack of information in large dataset, then suggests to add more knowledge in refund topic to reduce failure rate. In our platform, those observation narratives and counter proposals are given together, so human AI engineers only need to choose which may make sense. After picking up, AI evaluates alternative plans, again in the same steps. After evaluations, our agentic AI aggregates scores and compares which plan performs better than the others in each metric. Finally, AI judges the final rankings among the candidates. In this step, AI creates the overall narrative from the data report and judges the final rankings of each plan. This is coming from various reasoning steps with recapping all the objectives and directions from humans and machines reviewed results, but it helps guiding the best balanced one among candidates. In a demo screen example, sorry, it's a very tiny characters, but in the demo, one of the candidate plan performs better than the original plan in priority metrics and as suggested as the best, while some AI suggestions were eventually worse after experimentations. This visualizes how AI self-iterates from planning to reviewing actual logs and scores. So now, let me tell you some real development case studies. For example, we had a project to build a customer success agent that ensures, one, high satisfactions, but two, also seeks the upselling opportunities when possible. You create from scratch and draft with some AI assistant to use a single prompt text that includes all required instructions and using GPT-4o. Then AI generates and suggests the evaluation metrics of one, helpfulness to user inquiries as a customer success, two, relevance of upselling opportunities to user inquiries, three, CTA, call to action effectiveness, and four, follows the company's compliance. And those four metrics are balancedly aggregated. I do think this is a very relevant and balanced tailored KPI to the project objectives. Based on this KPI metric, AI generates and optimizes the LLM architecture by the steps described. Then finally, the just architecture works the best. One, decomposes generation into multiple steps, including analysis of the user intent and potential upselling opportunities, and using Llama 3.145B hosted on some inference. And for each knowledge document and the corpus, adds more context and use case scenarios along with the product information in order to improve the hit rate. I do think this approach is much more complex than the original one, but it's proven statistically that it works better. All of this can be done by human objective instructions and approvals upon checkpoints. The other use case is actually us. Our team matrix service has a lot of LLM-based AI to make it happen, and the complex architecture and prompt tuning was necessary to bring you the practical and proven values. But our team matrix is actually iterated on team matrix. For example, in the input dataset generator functions, like I've shown you this prompt engineering idea initially, but this idea to separate generation into multiple steps is first initiated by our AI. And with statistical proof that to best balance the desired diversity and latency in the majority of the cases. So we are sure that this is one of the proof that our AI can build an AI at the practical level. And we are sure that our capability will improve even more with team matrix in the near future. Sure. And we say this AI iteration cycle could be looped by AI to find an even optimal solution. Unlike machine learning that tunes and realizes parameters in a model, LLM AI doesn't actually acquire knowledge and learn in their model, but it's called an in-context learning that it responds using the given context without learnings, which is already proven by many speakers here today as a better development approach in AI today. In the era of in-context learning, we believe hypercycle of iteration is the key for building the best. With the automatic architecture, I'd like to call it the deep iteration as the new approach for further advance in LLM-based AI development, like we did in deep learning against machine learning. So how team matrix and deep iteration bring success to your research and development? So, and now self-testing on team matrix. One iteration is worth 37.5 hours of jobs by human developers and labelers. This is just a time cost for the testing and evaluation loop, and if you put more time on planning prompt engineering strategies or planning test cases, learnings, and general Python works, it costs more. I'm not saying it could save your time or it's a time-saving tool. I believe such a long R&D is too long to justify paying when you are at the prototype level or if you're not sure fully at what level LLM can work at the desired level ultimately. I worry many of you fail before going to the productions as you may not have reached to the desired quality with limited trials and errors. We assert that the scale testing and the consistent quantifications are the fundamental to iterate and productionize your LLM AI, but that is not practical to do them manually. Now, it's time to let AI do that. As a conclusion of my sessions, I'm proud to make an announcement of unveiling the first AI developer to the world. AI and LLM requires the work of continuous iteration, so do us. I'd like to ask you to be the first developer users of our revolutionary product and be part of shaping the future of AI development, and wish you to text me directly on the experience and new challenges you may face on our product. Or if you'd like to further deep dive, I'm at the booth of the 234, and come and talk to me. We have swag for you. If you already come, you can come to me again or text me. And the swags are like these characters is designed for you. So we are now a new startup challenging towards the technological singularities. But we believe today is the first milestone to make it happen. Together, we can redefine the boundaries of what AI can achieve. Let's build the AI together. Let's build a better AI together. Let's redesign how we build AI together. Thank you for listening.
This is Antonio. My question is, do you have a demo or something that demonstrates the improvements on maybe a simpler AI instance?
Sure. Thank you very much for asking. Due to some technology issues here, I cannot show you a demo on the screen, but you can try our product soon, or no, not now. You can try by subscribing to us, and you just register and try us. So it's now unveiled today. You can use it from today. Then after you try, by registering to our service, it's now for free as a beta, but during the beta version to test. And so feedback me if you have any challenges, experiences, then text direct me and feedback. Or if you have any specific
thank you very much.
Screens that you wish to have, no, I can answer. It's okay. One more question if you have. Okay.
Thank you so much for introducing AI, build AI for us. My question is that in terms of hallucination, what is the percentage that do you see the AI is working on? The percentage of hallucination.
Percentage of hallucination, it depends. We are the developing tool that tries to mitigate hallucinations. And of course, by having, for example, the custom metrics tailored, I do think hallucination can be defined differently in some specific cases. Like not only the universal metrics that it may hallucinate in, for example, tones or in the facts or accuracy based on the knowledge. So not only the groundedness, but the hallucination in general works differently as intended. However, on our AI, it builds the custom metrics tailored to evaluate your own application needs, and it also evaluates as an LLM as a judge. So it tries to score and visualize whether your application is hallucinating or not, and if it is failing in some minor cases, it tries to fix it.
I have a follow-up question.
Sure.
So let's say if we trust that your company product build a very good customer support AI for us, because we trust you, okay? Now build that customer support AI agent for us. Do we sit back and relax and feel for sure 100% that this customer support agent does a good job for us?
Okay, even after our product, I'm not saying the human AI engineer is no longer necessary, or rather, human AI engineer is required to be more creative and more intelligent and knowing whether the AI is aligning with the bigger project objectives. So unlike now, the human AI engineer has to catch up with the technical details and doing the heavy jobs, we are very happy spending on the creatives on whether it's aligns or not, and the bigger picture may be easily lost. first. But from us, it tries to visualize whether it is working on the score level. But also, the logs are ready. So human AI engineer can also review the logs and whether it aligns in the project objectives. But anyway, by letting your heavy work of development and letting AI to do it, you can spend more time to review whether it aligns and it works better, and it aligns with you.
One last question.
Okay.
Okay, it's a two-parts question. First question. So you have a curated list of base model to choose from, correct?
Correct.
Okay. How are you accounting for upcoming new models?
For upcoming new models, I do truly recommend to try it. But I cannot say the new models always work better. That is why I contextualize it in the first sessions. I do think the newer models have different approaches to build. For example, the quantizations to reduce the cost or have different parameter settings. So it may work in your applications, but it may not work. So I do recommend to try every new upcoming models to try whether it even improves your applications. But sometimes it may degrade. So that's why we have this platform to try first and evaluate in the evaluation metrics you define and whether it aligns better.
Yeah, my next question is, in the upcoming model, some of the steps that you mentioned can be actually pushed into the base model. For example, test case generation and the eval. That can be part of an agentic model that's in the near future, right?
Yes. Our test cases is generally to evaluate the in-context learning architecture. So it's not reviewing the overall model quality or not. They are already available on the public leaderboard. But our scores is actually a private leaderboard. It's whether it works in your needs. Right? All right. So if you have any more inquiries or wish to try or further deep dive, come to our booth, or you can text me directly on LinkedIn or whatever possible. And we are waiting for swags and other games on our booth, so visit us to get our cute swags. Yeah. All right. Thank you.